What does vitamin D look like? On this channel, I guess how something works and then find out how it actually works. If you want a more full explanation of the method that I'm using, then check out my other video on the channel. This guess starts with me placing myself on the Dunning-Kruger scale. But soon I will actually upload a video where I talk about how I feel like the Dunning-Kruger scale is way less useful than I first assumed. It doesn't seem to match the reality of the actual learning process, but at the time of recording this guess, I hadn't fully formed these thoughts yet. So let's start with the guessing. Here is me from the past. Am I just procrastinating? Yeah, what I'm trying to say is I feel like I'm like over here. When it comes to vitamin D, like I'm starting to feel like I almost know something about it. Okay, maybe I'm actually right here. I don't know. But the more I think about it, the more I think I'm barely even gonna be able to get like 1% correct. Like I still feel like I know more than an average person. The goal is to end up like somewhere over here, I guess, by the end of this video. No more procrastination. I don't know what I've done, you guys. I don't actually know anything about it. Let's just... Because I'm thinking... We're talking about vitamin D. It's a molecule. I'm trying to make like a cholesterol shape, but I can't remember. They weren't like this. They were maybe... No. Maybe... No. I guess I'm gonna have to put it there, but I don't really want to do that because this looks too symmetrical for some reason. Okay, what am I actually trying to do? It's not a hormone, of course. It's a vitamin. It's not a hormone. At this point, there are two major errors. One, vitamin D is a hormone. I'd assume that if something is a vitamin, then it can't be a hormone, but that's just not the case. A hormone is something that takes information from one location and travels to a different location and then changes something at that other location depending on the state of the first location, analogous to a messenger or a mailman. In what sense vitamin D is a hormone is something that we might discuss in a different video. 2. Vitamin D is not a vitamin. So this is something that I just would have never have guessed. And throughout the whole rest of this video, I will be under the assumption that vitamin D is a vitamin. So why is vitamin D not a vitamin? This has to do with the technicality of the definition of the word vitamin. They cannot be synthesized by the body. Since the body can make vitamin D itself, it is technically not a vitamin. You can, however, easily get vitamin D deficiency. I think it is made out of cholesterol. Cholesterol is... I don't know what it is. I'm thinking it's fat, but it's not fat. And actually, that was a really good way of putting it. 3 common fats are fatty acids, like omega oils, phospholipids that the membrane around each cell is made out of, and triglycerides, which is your body fat. Cholesterol is also a fat, yet the molecule looks very different to the other 3. And I'm also thinking it's a steroid. So here I was referring to cholesterol. And it is true that vitamin D is made out of cholesterol and also that cholesterol is a steroid. But what I didn't know is that cholesterol is actually the molecule that steroid hormones are made out of. If I'd known that, it would have been a clue that vitamin D is actually a hormone. Vitamin D is also almost a steroid, but I don't really want to talk about it in this video. There is this thing where vitamin D is being made inside of the body. I'm like 99% or more that it's made out of cholesterol. But could it also be made out of something else? And also, is it the good cholesterol or the bad cholesterol that it's made out of? I don't know. I feel like it should be the good cholesterol, right? Because vitamin D is good and the good cholesterol is good. So it should be made out of the good cholesterol. Because no one is going to tell you to eat more of the bad cholesterol, right? So it has to be like that, I think. In this guess, the assumption that I had made was that the good and bad cholesterol are two different molecules. But that is not the case. It is not the arrangement of the atoms in the molecule that makes it good or bad cholesterol. It is the context of which is being treated inside of the body. And actually, the terms good and bad cholesterol are a bit outdated, so I won't use them in this explanation. This is a lipoprotein. Lipoproteins transport cholesterol. It can pick up or unload cholesterol, giving it a different name, role and destination as it does so. The two main transporters of cholesterol are low-density lipoprotein and high-density lipoprotein. When there is a low amount of cholesterol in the body, it gets a lower density and transports the cholesterol to all the cells in the body. However, when it collects a lot of cholesterol and gets a high density, it transports it to the liver, where it might later be excreted. It is therefore the low-density cholesterol that has been transported from the liver to some specific cells in the skin that vitamin D is made out of. But it is also the low-density cholesterol that can get stuck in your blood vessels, and that is the leading cause of death in America. So with all of this information, which one do you think used to be called the good cholesterol and which one the bad cholesterol? It is the low-density cholesterol that is the one that used to be called the bad cholesterol. So even though I had completely misunderstood the situation, I was still wrong because I said vitamin D must be made out of the good cholesterol. Wow, okay, so let's go back to the guessing. Okay. Actually, I do like this shape. This one just looks too... What if we take out one of the corners like that? I'm trying to make the steroid shape, but I can't remember what it looks like exactly. And this is correct. That is the steroid backbone shape. Okay, before we continue, let me just add the double bonds. So the thing about vitamin D, as you know, is that people say that it comes from the sun, which is like one of my pet peeves, and that's why I claim that I know a little bit more than the regular people about vitamin D, because they seem to believe that the sun can give anything other than light and heat. It cannot. It only gives light and heat. The vitamin D is already in your body, but the sun has to activate it. That's like the thing that I know. But how does it actually work? And then here. Yeah. Let's just add a carbonyl here because it looks so wrong, so I just want to fix it a little bit. Obviously it's still wrong because it would be impossible that it would look this this simple. It's not gonna look it's definitely not gonna look like this. I was correct, this is not vitamin D. However, except for this double bond and the carbonyl, this is a real molecule that actually does exist. Anyway, let's have a look at what the actual vitamin D molecule looks like. I was actually surprised to find out that I was even this close. The real vitamin D had way fewer double bonds than what I thought. And when I was making this guess, I was thinking about another molecule that also interacts with the sun. Chlorophyll. And I had just assumed that in order to interact with the sun, you're gonna need a lot of double bonds, where every other bond is a double bond and every other bond is a single bond. But turns out that's not the case. And that is the end of this video, but it's not the end of this topic because I have a bunch of more guesses recorded about vitamin D, but I don't know when, if ever, they're going to get uploaded because the next video is going to be either about the ear or about cancer. I know we barely even scratched the surface on this one, so subscribe if you want more of the same. And if you want to be my hero, you can give a like.